Next up, we're going to look at performing exploratory data analysis and just a few basic visualizations. So the first thing we're going to do to explore this data is see, are there missing observations? And there's a number of ways we've discussed how to do this. We can graph it, we can use info, we can do the method I'm going to do on the screen, and there's plenty of other ways that we did not discuss in this class as well. But for instance here, what we're going to do is I'm going to take our data set, I'm going to pass is null, again saying if it's a missing value or a null value, fill in a value of 1, otherwise a value of 0, and we're going to sum that. So if we sum up all the number ones, that's going to tell us how many missing observations there are. And perfectly, what we have here is a data set with 0 missing observations. Every stock has a price on every day in our data. Here we're going to run info on it. And we'll see again, there are 2,201 observations. All of them are non-null or not missing values. We can see date is formatted as a date type, which is perfect, a date time variable. Everything else is a float, so it did correctly come in as a numeric variable, and it seems like our data set is in good shape to go ahead and start working with. So the first thing we're going to do is a basic visualization. We're going to define a function, and we're going to plot the entire data frame. And I will tell you right now that the theme of these set of lectures is not only working with finance data, but is going to be in working with functions, creating our own functions, starting with a simple one and working our way up through a very difficult to write function. And those functions, although challenging and frustrating at first when you learn to write them, will save you immense amounts of time later on. You can copy and paste these functions from notebook to notebook, and they will accomplish tasks that you are going to do many, many times as you work with data. So rather than continuously rewriting code to do something, we can simply utilize these functions that we have written once, and it's going to save us a lot of time. It's also usually going to allow us to do things across many observations because they will oftentimes include for loops as we get down into some of the more complicated ones. But again, functions are frustrating to write. They can be very difficult at the beginning, but as you become more and more familiar with creating them, you'll see that they're really not that complicated once you get the hang of it. So as I mentioned, let's start out with a simple one. We're going to define a function to plot the entire data frame. It's going to take a data frame as input. Nothing's going to be returned back right away. We're going to have to do something for that to be returned. And what it's going to do is perform data visualization. So the way we set up a function is we are going to write the word def, because we're going to define our function. And we're going to have to give our function a name. The name is whatever you want it to be. I would hope it's easier, at least, if you make a name that is informative. So I'd hope you use something informative, but it's up to you. I called this one show_plot because I want it to show a plot. After we write the title of our function, we're going to put a set of parentheses. Within those parentheses, we get to tell it which arguments do you want to have passed to it. We're going to have an argument that we're just going to call df, and another argument that we're going to call fig_title. And then we finish this off with a colon. When you hit enter, you notice here that we have an indentation. This is required. When we write a function, just like when we did for loops, we have to indent so that Python knows everything now that is indented is part of this function. So the first thing we're going to do is say df.plot, and df in this case refers to whichever data frame we pass in, and you'll see what I mean here in a moment. So df.plot, where x is the date, our x-axis is going to be the date, fig size. This simply tells us, or tells Python, how large or small do we want this figure to print as. So you can change that and you'll see that the figure that you print is going to be a different size. Line width, also how thick is the line that we're plotting. In title, do we need a title? Well, we don't need one, but we want one, so title is equal to fig_title. And that is the value we're going to pass in here. And again, you'll see how this works in a moment as well. plt.grid, just another formatting step. I'm going to plot a grid over top of it, and you'll see what that looks like. And then plt.show. This means show the graph. Show everything that we have put in as characteristics of this graph. So when we run this, as I mentioned, nothing happens, right? We do not get anything returned back to us. And that's because all we have done at this point is created the function. Now we actually have to call that function, pass in data to it in order to get something back. So in this next bit of code, I'm saying show underscore plot. That is the name of our function, so we're calling the function. Up here, remember, our function requires two inputs, df, so a data frame, and fig underscore title, which is just a title for this figure. If you come down here, our data frame is called stocks underscore df. So we're going to pass that in as our data source, a comma, just like above, and we're going to title our figure something, raw stock prices without normalization. And we're going to do it with normalization later, so if you don't know what that is, don't worry, we haven't talked about it yet. So we go ahead and run this. Here's what you have. We have our figure with our grid. We have date along the x-axis. We have our fig title up at the top. We have a nice key or legend over here, and here are the prices throughout time for each of the stocks in our sample.